Hello and welcome to yet another ISA 4220 presentation. I'm Patrick White and today we will be discussing SSH. So what is SSH? It stands for Secure Socket Shell, or more simply put, Secure Shell. And it is an encrypted remote administration protocol that allows clients to connect to, control, and modify remote servers. Prior to SSH, we actually used Telnet to do machine-to-machine connections, and it actually utilized the internet to create an unencrypted connection. And it was very unsecure, so we have eventually replaced it with SSH, which provides an encrypted connection. SSH is available on Linux and Windows. For Linux, it's very simple to install and utilize, just a couple commands in the terminal. As for Windows, you're going to need to download an SSH client, most popular one being PuTTY. And SSH follows a client-server model in which a client communicates to a server, vice versa. They both both utilize port 22 for SSH by default. And SSH utilizes authentication and encryption. So the authentication being either password or keys. And the encryption, it actually uses multiple methods of encryption for various stages of the connection, including symmetrical, asymmetrical, and hashing. So the symmetrical will basically be used for all the communication between the two. So the symmetrical will, or also known as the shared key or shared secret encryption, they're going to be used to encrypt the entire communication during an SSH session. Both the client and the server will derive the secret key using an agreed upon method, and the process of creating the key is carried out by a key exchange algorithm. And with this algorithm, the key is never transmitted between the client and the host. Instead, the two computers, the client and the host, will share public pieces of data that they can then manipulate to calculate the key. So even if another machine is able to capture the shared data, they're not going to be able to get the key from it because only the key exchange, the key exchange algorithm is not known by the outside computer. So as for asymmetric, it uses two separate keys instead of a shared key. So the two separate keys are going to be the public key and the private key. This is known as a public-private key pair. The public key is openly distributed and shared with all parties, and it is closely linked with the private key in terms of functionality, but the private key cannot be mathematically computed from the public key. So the private key must remain private for the connection to be secured, and that's basically what the entire asymmetrical security is based on, that private key remaining private. And the third method that SSH utilizes is hashing. It's just a form of cryptography used in SSH. And SSH actually uses one-way hashes. They will basically generate a value of fixed length for each input. It shows no clear trend which can be exploited by outside parties, and that's what makes one-way hashes pretty much impossible to reverse. So SSH uses hashes to actually verify the authenticity of messages. uses HMAX or hash-based message authentication codes. This basically ensures the command received is not tampered with during the communication process. So each message that is transmitted will contain an MAC, or a message authentication code. It is then calculated using the symmetric key, the packet sequence number, and the message contents. So after that, it is sent outside the symmetrically encrypted data, and the concluding section of the communication package will be sent. So SSH uses multiple ways to encrypt in various stages of the SSH connection. So, how do you use SSH? Well, for our purposes of the class, we're using it in Linux, or actually Linux and Viata technically, but you're gonna want to type in this command here, SSH user at host. The user will signify which profile you're going to be logging into, and the host is obviously the location of the server, the IP address. A couple other things about SSH. The command to install it on Ubuntu or Linux will be this sudo apt-get install OpenSSH server, and you're going to need sudo or root privileges to do that. And the remote machine or server must have SSH daemon software, and the user's machine must also have an SSH client. Both of these things are needed for an SSH connection to actually happen. So let's talk about how do you harden your client server SSH connection. Well, first you're going to want to make sure you're using keys instead of a password to authenticate. For this reason, passwords are commonly cracked by people using bots and brute forcing it. So you want to use an SSH key. You basically just generate a key pair, and you're going to want to add them into some of the SSH config files, and you're also going to need to share the public key, and after that you'll have some keys. So the next step for hardening is you want to change the port that the SSH daemon is running on. So like I said, by default SSH, the server will be listening to port 22, so if you want to change that port to something else, it will reduce the amount of script kiddies and stuff that are going to target that port. So if you change the default port, maybe the attacks will decrease. So basically for this one, you need to go into the configuration file, find the line that says port 22, and then change it to something else like 2222. But I mean, a lot of people know that 4.2s is an alternative, so they'll start going for that one next. The next hardening tip is you want to limit the users who can connect through SSH, and this is basically just a whitelist, and it will initially deny everyone access, and the whitelist will create a list of the users that will be allowed to log in SSH. It's simply just going into the configuration file, finding the line, or not finding the line, actually you're going to add a line that says allow users, and then the name of the user that you want to add. And yeah, that's it for whitelist. Disabling root login. Now, obviously this is a hardening method that can be used in a multitude of things. having root login will allow people to have unnecessary control over the system. So you want to be connecting as a user with sudo permission. So you want to make sure that user has sudo set up properly before you try to. Basically, it's just in the configuration file. You want to find the line that says permit root login. It'll say yes by default. So change that to no, and that will disable root login. The next step you want to do is disable X11 forwarding. So since we're using a remote server, there's no reason for a GUI or to use a GUI for a remote server. So we want to disable the X11 forwarding. You want to go into the configuration, find the line that says X11 forwarding. It'll be yes by default, and we want to change that to no. And the final step for hardening your SSH connection is going to be using banners and MOTD. Basically what these things are is they're just going to be messages that will be sent to people. The system will announce some system info if you try to connect to the server with, say, a fake user. And so the banner is sent out before authentication actually happens. Everyone attempting to connect through SSH will see this banner. So to make sure this banner isn't giving away any vital information, you need to edit the configuration file. Yeah, and you'll be able to basically put any message you want there. A lot of people put like SCI pictures and stuff. MOTD, or message of the day, is shown after users log in. It can give away information in the header of the message, and that's something else that you can configure and change to however you want. So understanding how banners work, it's important to make sure your system's not just giving out info without you even knowing it. So that's just something you want to look over before you start actually using the SSH connection protocol. And that about covers everything. Here's some of my references, and hope you all have a nice day. Thanks for watching.